Hello students, welcome to Organic Chemverse YouTube channel. In this video, I am going to explain heat of combustion for alkane molecules. This is very interesting topic, so let's get started. What is heat of combustion for alkane molecules? It is the energy released during the complete combustion. What exactly it means? Say when you take an alkane, combustion is reacting with oxygen, right? So it always forms carbon dioxide and water. Then only we call it as complete combustion. And energy is always liberated. Whenever the energy is liberated, we know that this is a exothermic process. Whenever it is exothermic process, we know that the energy liberated, we indicate it in terms of negative values. Why we need to study this heat of combustion? Because it is a key factor comparing the stability of alkanes. So let's compare some alkanes. Students, remember, as the number of carbons increases in a straight chain, the heat of combustion will also increase. For every CH2 group added to an alkane, usually the 654 kilojoule per mole of energy is liberated. Now, what about isomers? Because isomers will have same number of carbons, isn't it? For isomers, the heat of combustion is inversely proportional to the stability. How do we know about the stability and the structure of molecules? Remember, a branched alkane are more stable than their straight chain. So higher the heat of combustion, less will be the stability. Now, what about for cycloalkanes? For cycloalkanes, it's something to do with the stability of molecules as well, till cyclohexane molecule. So what I mean is, more the angle strain in a molecule, less will be the stability. Lesser the stability, higher the heat of combustion. That means for cyclopropane, the heat of combustion is greater than that of cyclobutane, then cyclopentane and cyclohexane. But after cyclohexane, that means after 6 carbons, like for cycloheptane, octane. So we are going to consider the concept of CH2 group. More the CH2 groups added, more will be the heat of combustion. So these are the basic principles or the concepts you have to remember in order to answer the given questions. So let's read out the questions. Which of the following has the largest heat of combustion? So we have ethyl cyclopentane, ethyl cyclohexane, ethyl cyclobutane, ethyl cycloheptane. Ethyl is common among all the given options, but the number of carbons in the cyclic chain is different. As I told you, as the number of carbons increases, right? So for cycloheptane, we know there are 7 carbons. Therefore, the heat of combustion will also be more for this. Therefore, the right option is option D. Now, which of the following molecules has the most negative heat of combustion in kilocal per mole? Methane, ethane, propane, butane. Remember, the negative indicates the exothermic process. And we know that as the number of carbons increases, the heat of combustion increases. So the most negative value would be for butane. Therefore, the right option here is also option D. I hope it's clear to you how to solve questions based on the heat of combustion. Thank you for watching this video.